42. Students attach a light string to a cart. The string passes over an ideal pulley to a hanger. A number of small identical plates are on both the cart and the hanger. The students measure the acceleration of the cart when the cart hanger plate system is released from rest. The students repeat this procedure for several trials. For each trial, students move one plate from the cart onto the hanger. The data are collected and shown in a straight line graph. Which quantities on the vertical and horizontal axis respectively could produce the graph shown? Now, in this case, you want to consider what are the forces being exerted during this process. And you can see that there is only one external force, which is the mass on the hanger times the gravitational acceleration, because the tension is approximately the same on both ends of the string. The gravitational force and normal force on the cart are irrelevant to the acceleration of the cart. So, the only force that you need to consider for Newton's second law is the force exerted by the mass on the hanger. Now, according to Newton's second law, the net force is supposed to be equal to the mass of the system times the acceleration. Now, the mass of the system is a constant, so the acceleration is equal to the constant mass of the system, reciprocal of that, times the net force, which is the mass on the hanger, times g. This means that the acceleration is equal to the constant g over mass of the system times the mass on the hanger. The greater mass on the hanger produces a greater acceleration. So you could have that the acceleration is on the vertical axis and the mass on the hanger on the horizontal axis. And that is option A.